My name is Suja, and today Kira and I will be discussing the paper titled Hierarchical Classification by Rank and Kinship in Baboons from Science Magazine, written by Thor J. Bergman, Jacinta C. Beener, Dorothy L. Cheney, and Robert M. Sayforth. We will begin by introducing some background on what led these researchers to develop their particular research questions. Humans have the ability to recognize that certain individuals are more dominant or more subordinate to others, as well as the ability to recognize kin or familial relationships in others, and that people's individual qualities can be affected based on which groups they're affiliated with. Non-human primates also share the ability to recognize other individuals' dominance, ranks, and kin relations, but it is unknown if they can use both criteria together to rank other individuals like humans can. With Old World monkeys, which includes baboons, macaques, and vervets, the dominance hierarchy is linear, where all females in one matriline outrank or are outranked by all females in another. In addition, threats are usually directed by higher ranking individuals to lower ranking individuals, while alliances target subordinate opponents. Ranks in the same matrilineal kin group usually stay the same, but occasionally there can be within or between family rank reversal events. The more impactful of these is the between family rank reversal, which can cause social upheaval purely by the amount of individuals and their ranks that are affected. It is already known that monkeys can recognize matrilineal kin and close associates of other group members, as well as the relative dominance ranks of others. The unknown part is whether they are able to do this simultaneously, and this is what this particular paper discusses. Bergman et al. Designed a playback experiment in order to investigate the question of whether monkeys can evaluate other monkeys according to both rank and kinship at the same time, or whether they can combine their knowledge of rank and kinship in order to identify that some rank reversals could have more social importance than others.
The researchers in this experiment hypothesized that the baboons would respond more strongly to the sequences involving rank reversals than to the control sequence. Furthermore, they predicted that if the baboons were equally sensitive to both rank and kinship, they would respond more strongly to the call mimicking a between family rank reversal than to the call mimicking a within family rank reversal. This is based on the prediction that a between family rank reversal would signal a change in dominance relations in two different matrilines and would affect the ranks of many individuals, not just two, and therefore appear more important to the baboon. In other words, changing the rank between two different families would disrupt multiple lines and cause a more widespread change in hierarchy, eliciting a louder and more urgent response from the individual.
The researchers designed a playback experiment where the female baboons were played sequence of calls which mimicked a fight between two other females. Call sequences were made of threat grunts, which are produced when female baboons threaten subordinate individuals, combined with screams of another, which are produced when an animal is being threatened by a dominant individual. 19 adult female baboons above the age of 6 in Botswana were used in this experiment. Matrilineal kinship for all were known, and the definition of a matriline for this experiment included up to first cousin level. With within family rank reversal sequences, researchers chose more close relations such as mother and daughter, sisters, or nieces and aunts. It was designed with a within subject design, and the same subject heard one of 3 different call sequences on separate days. The first type of call sequence was a threat grunt scream sequence mimicking within family rank reversal. The second type was a sequence mimicking between family rank reversal. And finally, there was a no reversal control sequence consistent with female dominance hierarchy. The vocalizations of all 19 were made into sequences, and these were played for the other completely unrelated subjects. Overall, the experiment showed a significant difference in duration of subject responses to 3 different call sequences. Responses to apparent rank reversals were unrelated to rank distance separating the two signalers. Subject responses were not affected by relative frequency of fights among kin as opposed to non-kin. Aggressive interactions that included threat grunts and screams were on average 5.4 times per 1,000 observational hours, with 6.5 times per 1,000 hours for non-kin dyads. Aggressive interactions never involved threats or screams that violated the dominance hierarchy. Figure 1 illustrates the differences in duration of subject responses to the three call sequences. As you can see, there are three categories of between family, within family, and no reversal control, with the average duration of looking being around 4 seconds, around 2 seconds, and around 1.5 seconds, respectively. Subjects look toward the speaker for significantly longer durations when hearing sequences with between family rank reversal than when hearing both within and no reversal control sequences. While subjects on average looked longer at within family than control, the difference was not significant enough. With control sequences, subjects looked just as long at sequences that mimicked within family as those that mimicked between family disputes. Responses to apparent rank reversals were unrelated to rank distance separating the two signalers. Figure 2 shows a graph of rank difference versus response duration for both within and between family rank reversal sequences. For both, subjects looked equally long at apparent reversals with closely ranked opponents as with more distantly ranked opponents. This was possibly due to novelty of closeness between different matrilines, but females were more likely to have non-kin than kin as their nearest neighbor.
This experiment provides evidence that monkeys classify each other simultaneously based on both their individual attributes and membership in higher order groups. For humans, it's like how we evaluate and categorize a person based on their role in a family, for example, whether they're a sister, mother, uncle, etc., as well as the social class of that person's family. From this experiment, we can see that baboons are able to recognize the matrilineal subdivisions of their group's female dominance hierarchy, meaning they can see that there are lines of hierarchy within hierarchy. We can also see that although ranks exist within both families, between families, and within families, baboons understand that these ranks have different meanings. They too can recognize different levels of authority and understand how these relationships come into play in a more holistic sense. Moreover, we can even use this experiment to draw connections between baboon and human cognition. This particular study suggests that the evolution of human language has a connection to baboons and their skills in higher order thinking. For years, we've known that humans make meaning out of sentences by grouping words into nouns, adjectives, verbs, and so on, which is essentially arranging words by hierarchical groups. However, we don't know whether this technique of using rule-governed hierarchical groups is specific to language itself, or whether it has evolved to serve other non-linguistic purposes, like in social relations. In other words, does our ability to recognize people, faces, and social groups in our heads come from language learning, or are they two separate functions entirely? Though this is still unclear, we can see from this experiment that baboons organize their peers into a hierarchical structure based on kinship and rank. Although they don't have the same language abilities that we do, this reveals that they may have cognitive skills that are somehow linked to human language and behavior. Since humans and baboons seem to show significant similarities in cognitive ability, other research has been done investigating cognitive set in baboons as it relates to humans. Breaking cognitive set is the ability to switch to a more efficient method of solving a task when it becomes available. One study shows that baboons were actually better at breaking cognitive set than humans, suggesting that baboons are more advanced in some areas of cognition than humans are. Another study shows that baboons also have the ability to judge whether objects are the same or different. For example, if we had a penny in one hand and a nickel in another, we would know that the two objects are different. If we had pennies in both hands, we would register the objects as the same. According to the study, baboons are able to make that same connection, suggesting that they are capable of learning the relation between relations. These studies show that humans and primates are more closely related than we previously believed, and that although people are generally thought of as smarter and more capable beings, the gap between primate and human intelligence might not be as large as one may think. It's safe to say that much of the social classifications we've done as humans have had serious implications in both our past and current social and political climate. Although it may not have the same consequences for these primates, understanding how and why animals are able to recognize social hierarchy is important insight into understanding the evolutionary background we share with our ancestors. Plus, further research that stems from these studies allow us to understand the freedoms and limitations of the animal mind, which can lead to new ways that humans and animals can be of service to each other. Though the two other experiments that I mentioned test different areas of cognition than our study at hand, they all suggest that baboons have comparable cognitive skills to humans and may even possess more advanced abilities in some areas. Being able to categorize objects, recognize social structure, and efficiently learn new skills or relations are areas that scientists have taken special interest in and are continuing to research in order to understand the vast evolutionary connection between humans and primates. Thank you so much. That concludes our presentation.